In this video, I will explain what are the minor losses in piping systems and how we can calculate them. Minor losses are the flow losses from pipe elbows and bends. Pipe elbows and bends can be 90-degree and 180-degree bend. Losses from pipe tees in the pipe branch or from the valves. There are also flow losses from pipe entrance geometry type. The entrance can be sharp-edged or rounded edge. The loss can be reduced by rounding of the edges. Pipe entrance are important when transporting fluid from a large reservoir. Then the flow losses from the pipe exit geometry. The exit geometry can be retrent, sharp-edged or rounded. In practice, these exits are opening in large reservoirs, and losses in cross-sectional area changes where the diameter of pipe is increased or decreased. There are flow losses from the flow nozzles, in which the flow velocity is increased from the orifice plates, which are used for flow measurements, and screens, which are used as filters. So minor losses are the energy loss from the valves, elbows, tees, inlet, exits, enlargements, and contraction in a piping system is due to viscous effects and turbulent eddies that are produced downstream. These eddies waste mechanical energy that is dissipated into heat. Minor losses are determined experimentally by the manufacturer of the component and expressed in terms of the loss coefficient. If we have the pressure drop value and velocity through the pipe, we can find out the loss coefficient by this expression, where KL represents the loss coefficient. After knowing the loss coefficient KL, we can find out the head loss from this valve or any other pipe component. Minor losses are also expressed in terms of equivalent length. When we have this loss coefficient KL, we can find out the equivalent length. This equivalent length will be added to the total length of the pipe to find out the total loss in the piping system. Therefore, the total head loss in a piping system is the sum of major head loss and the minor head loss. Major head loss is due to the straight pipes and minor head loss is due to the components of the piping system. The major head loss is a function of Darcy friction factor, length, average velocity, and diameter of the pipe, but the minor head loss is a function of the loss coefficient KL and average velocity. So total head loss can be written in this form when the diameter of the pipe is constant. Now I will discuss the loss at the pipe entrance geometry. You might have seen the reservoirs with water or any other fluid transport fluid with the help of pipes. The pipe entrance can be sharp-edged or rounded edge. This sharp edge has greater flow losses as compared to this rounded edge pipe entrance. This is due to the flow separation region, which reduces the flow area. This flow separation region is also called as vena contracta. The flow velocity is increased in this reduced effective flow area and then decreases at point 2. The flow velocity is minimum at point 0, maximum at point 1, and then decreases at point 2. The loss in the kinetic energy is dissipated in the form of heat. As the roundness of edge increases, the loss coefficient is decreasing, where small r is the radius of this rounded edge and capital D is the diameter of pipe. For the sharp edge, the value of KL is 0.5, and for well-rounded pipe entrance, the KL value is 0.03. Now we will discuss the loss at the pipe exits. These are the pipe exits which are opening in large reservoirs of fluid. The pipe exits can be reentrant, sharp-edged or rounded. For all these three pipe exits, the KL value is equal to alpha, where alpha is velocity correction factor and its value is equal to 1 for turbulent flow and it is equal to 2 for laminar flows. The loss at the sudden pipe contraction can be determined by using this graph, where A2 is the area of cross-section for smaller pipe and A1 is the area of cross-section for larger pipe. When A1 is very large from the A2, it will make the same condition like the pipe entrance from a reservoir for which the value of KL was equal to 0.5. The loss from the sudden pipe expansion can be found by using this expression of KL. In this expression, A1 is the area of smaller pipe and A3 is the area of larger pipe. The loss due to the gradual pipe expansion and contraction can be found by this figure. The value of KL varies due to the enclosed angle theta. We can see that as the angle is increased, the value of KL is increasing for expansion, but for contraction, the value of KL depends on the ratio of small d to capital D. As this ratio increases, the value of KL decreases. The loss from the pipe bends and elbows can be found by using these values of KL. For the sharp turn, KL value is equal to 1.1 and for the well-rounded elbow, KL is equal to 0.3. There are different pipe bends and this figure shows us the reference values of KL for different types of bends and elbows. This figure will be used for calculation of head loss from any type of bends or elbows T's. There are flow losses from valves and we have different types of valves available. The reference values of KL are given in this table for globe valve, angle valve, ball valve, swing check valve and gate valve. These values of KL will be used to find out the pressure loss from these valves. Thank you for watching this video. In my next videos, I will present few examples to calculate the minor losses in a piping system design.